Today's lesson, we're just going to have a look at working out the area of circles and sectors. So in our last lesson, we looked at how to work out the area of 6 different basic shapes. Now we're going to look at how to work out the area of circles, and stemming from that, how to work out the area of sectors. So let's get straight into it. We all know what a circle is, and we're probably familiar with the rule for the area of a circle. So when we're looking at circles, there's just one rule that we need to remember. So keeping in mind the sections of our circle, the rule that we use to work out the area of a circle is area is equal to pi r squared, and keeping in mind that r is just our radius, which is half of the diameter. So remember those things as you do your area of a circle questions, and it really is that simple. It's a small little rule. Area is equal to pi r squared, and we just apply that whenever we want to work out the area of a circle. So let's have a go at a little example. It's probably the best way to show it. Now, I'm sure you guys have done this before, so it's probably just a bit of a refresh. If you're a bit rusty, now's your time to catch up a little bit. Okay, so let's say our radius is 2 centimeters, and I want to find the area of this circle. Area, we always start with our rule, pi r squared, and then we go and substitute our dimensions that we know. My radius is 2, so it'll be 2 squared, which is pi times by 4, and at this point I'm going to put that into my calculator. So that gives us, let's have a look, pi, whoopsies, 12.57. And our units are centimeters squared. So it's an area, so we always do units squared, whatever our original units were, and we square them. So I'm going to give you guys an example to work through now. See if you can find the area of this circle with a radius of 6 meters. So pause the video at this point, go and work out the area of that circle, come back and see if you got it right. Okay, so I hope you've all had a go at it. Now, if we want to find the area is equal to pi r squared. Write the rule every single time. Pi 6 squared. So putting those brackets there just indicates that there's a multiplication separating those two terms. And we have 113.097, so if we're going to go to 2 decimal places, 10 units are meters squared this time. So we should have all got 113.10 meters squared for that one. We can make these a little bit trickier by doing a conversion at the start. So we might have a circle which gives us the diameter rather than the radius. We said at the start of the lesson the diameter is just 2 lots of the radius. So if our diameter is 10 millimeters, the way I would find the area, very first, write my rule, pi r squared. Only problem is we don't have radius, we have diameter. So off to the side, we need to do a little conversion. So radius is equal to my diameter divided by 2. It's just half of the diameter. 10 divided by 2 is 5 millimeters. Now we have our radius. We can go and plug that back into the rule that we wrote earlier. So pi times by 5 squared. And if we put that in our calculator, we get 78.54 millimeters squared. And that's how we work out the area of a circle when given the diameter rather than the radius. Okay, now that we've looked at how to find the area of a circle when either given the radius or the diameter, we're going to look at how to work out the area of a sector. And the reason we do this all in one lesson is because a sector is just a part of a circle. So if you know how to work out the area of a circle, you'll know how to work out the area of a sector. So just to reiterate, a sector is just a fraction of a circle. So it might be a little wedge that's taken out of a circle. So if we can imagine our circle that was a terrible diagram, but something like that. So it's just a wedge taken out of a circle. And because of that, the steps to working out the area of a sector are actually kind of similar to the steps that we take for working out the area of a circle. Sorry about that dodgy diagram. So what we would have in this diagram are some dimensions. So we have an angle in here, which we're going to call theta. You guys would have seen the symbol theta when doing trigonometry in the past. So we have theta in there, and we also have this length across here, and we need to think to ourselves, well, what is that length? It's a length that we know, but what is it? So I'm going to go ahead and draw that large circle diagram back on. That's a little bit better than before. If we look at that circle, this length that we have right here is just really the radius, isn't it? It goes to the center of the circle halfway across, so it's just our radius. So whenever we have a sector, the edge that goes towards the point is actually just our radius. So not the curved edge, but the straight edge that goes towards the point. And that point is always going to be in the exact center of our circle. So that's our radius. So when we get given a sector, we have two measurements that we need to know. It's the radius and theta. So I'll redraw that diagram here without the rest of the circle attached. We have theta and radius. Keeping in mind theta is just an angle. Now, one thing to remember when doing an area of a sector question is how many degrees were there originally in the circle. So from start to finish, as we go around the circle, we know we have 360 degrees. So let's keep that in mind as we do these questions. The best way to do this one is going to be with an example. So we're going to jump straight in with an example. And then we'll go and fill out our rule. So let's just say I have this sector here. We've got 40 degrees, or let's say 60 degrees. Oops. Not a great diagram, but does the trick. 60 degrees, and I have a radius length of 4 meters, and I want to find the area of that sector, so that piece of a circle. Well, I know the area of a circle, if it was a whole circle, is pi r squared. The problem is it's not a whole circle, it's just a fraction of a circle. And in maths, when we use the word of, it actually means multiply. So we've got some fraction, something over something, of our whole area. So we need to work out what that fraction of the whole area is. So what is that fraction? Well, if this was a whole circle, we said before, there would be from start all the way back around, there would be 360 degrees. But we've only got 60 degrees of that. So we have 60 out of a total 360 degrees. So that's the fraction of the circle that we've got. We've got 60 out of 360 degrees, and that's how we find the area of this sector. We have the fraction of the whole circle multiplied by pi r squared, and in this case, 60 over 360, my radius is pi 4 squared, so my radius is 4. So just to reiterate, we have a fraction of being multiplied our whole area. So the fraction of the whole area gives us the area of just the sector. And that rule applies every time you do the area of a sector. You just obviously write in whatever angle that you're working with. And there's always a total of 360, doesn't matter what circle. So something out of 360 multiplied by your regular area rule. So let's go and pop that in a calculator. Pi times by, and we get 8.377, so 8.38. Units are meters. It's still an area, so it's meters squared. Now, if we want to just generalize that, let's go and write a rule up above. So when we want to find the area of a sector, the rule that we use is area is equal to theta over 360. So that's just the angle that we're working with, multiplied by pi r squared. So there's really just one more thing we need to know. So pi r squared is when we're working out the area of a circle. Theta over 360 multiplied by pi r squared is the area of a sector. So when we're doing areas of sectors, instead of just needing to know r, we need to know r and theta. So we've got two unknowns there that we need to know. But the actual math, the doing of the equation, is not really much more difficult. There's just another step to remember. Okay, I'm going to do an example for you guys to follow along with. Sorry, for you guys to have a go at. So I would like you to have a go at finding the area of this sector. So we've got 30 degrees and a radius of 10 centimeters. So at this point, I'd like you to pause the video, have a go at finding the area of that sector, and then come back and check that you've got the correct answer. Okay, I hope everyone had a go at finding the area of that sector. Let's go through the solution. So the very first thing we do, area is equal to, we write our rule, so it's a sector. So it's pi over 360 multiplied by, theta over 360 multiplied by pi r squared. We've got our theta, 30 degrees, and we've got our radius. So we have 30 over 360 multiplied by pi 10 squared. And putting that into our calculator, we get times by, what's these? 26.18. So just rounding to 2 decimal places there. 18, and my units are centimeters squared. It's still an area, so it's centimeters squared. Okay, I will put the relevant textbook questions just underneath here. I'll put a photo of them or a screenshot of them, so you guys can go and practice working at the area of circles and sectors. In our next lesson, we'll have a look at surface area. But for now, I'd like you guys to work on finding the area of circles and sectors, and I hope you've finished, or at least getting towards finishing, the questions on the area of all of those other shapes. Okay, good luck.